Suppose a car travels down a straight road at a constant velocity of 60 miles per hour for 40 seconds. How far did the car travel during this time? Well, if it was a constant velocity of 60 miles per hour, then we could use the formula distance equals velocity times time. This works when you have a constant velocity. The only problem is we have a velocity in miles per hour and we have a time in seconds. We need to make sure that our units are compatible. So we have to do a little bit of unit conversion. So the conversions that we need are 1 mile is 5,280 feet, and 1 hour is 3,600 seconds. So to do a unit conversion, start with what we want to convert. In this case, that's 60 miles per hour. So I'm going to write it like this. We have 60 miles. The abbreviation for miles is MI. And this is per, which means divide, hour. And I'm going to multiply this by, well, in this case, let's do we'll do the miles first. So I'm going to multiply it by this conversion right here, but I want the miles to cancel, which means the miles are going to have to be down here. And so I know that 1 mile is equal to 5,280 feet. And the abbreviation for feet is FT. Now I want to convert the hours here into seconds. So the hours are down here, which means in order to cancel when I multiply everything out, I need hours to be on top. So for my second conversion, I'm going to have 1 hour. H is the abbreviation for hour. And that's equivalent to 3,600 seconds. And I can use S for seconds. And so if you multiply all this out, you see that the miles end up canceling, the hours end up canceling, and I'm left with feet per second. So I'm going to do 60 times 5,280 divided by 3,600. So when you do this unit conversion, you end up getting 88 feet per second. So now that I have units that make sense, now I can actually calculate my distance. And so the distance then, I'll call it D for distance. Distance would be velocity, well, it's 88 feet per second, times the time, that was 40 seconds. And you see the units work out so that the seconds end up canceling and you're left with feet. And when you do this, you get 3,520 feet. Okay, so that was pretty easy when we have a constant velocity, but what if we don't have a constant velocity? Then what do you do? So same deal, we have a car traveling down a straight road, except this time we're going to sample the velocity every 2 seconds for 10 seconds. And this is what we get. So at 0 seconds when we start, the car is going 50 miles per hour. And then 2 seconds later, it's going 52 miles per hour, and so on. And I guess the first thing we should do is put the units so that they're all the same kind of unit. We don't want to have hours and seconds here. So let's convert this miles per hour to feet per second, which for some reason mathematics textbooks love feet per second. If you were doing this in a science class like physics, you probably want to use meters per second, but I'm going to go with the math convention here. Feet per second. So if you do the conversion from miles per hour to feet per second, then the table looks like this. Okay, now what? Well, let's look at the table of values here and let's graph it. So we would get a graph that looks something like this. So we're just plotting a bunch of points here. And I want to try and estimate the distance traveled because it's going to be kind of hard to get an exact answer. I don't know what happened in between the sampling points. But maybe I can use an estimate here. So I want to use this formula distance equals velocity times time, but I can only use that if I have a constant velocity. So let's see here. How about for the first 2 seconds here, if we just assume that the car traveled at a constant 73.3 feet per second. So in that case, my distance for that part would be 73.3 feet per second. And then the time would be 2 seconds. Okay? All right. Well, I mean, that's a little unrealistic right here, but at least we have something we can use for a constant interval here. How about this? Then for the next one, we'll have it jump up to this value here, and we'll say that it stays constant. In this case, that's 76.3. So for the next 2 seconds, I can tack on a 76.3 meters per second, sorry, feet per second, times 2 seconds. Okay, you can see what we're going to do here. We're going to keep doing this idea of picking constant intervals so we can use this formula here. So now we're going to use 82.1, and this will be feet per second for 2 seconds. And then the next one will be up here. So these are supposed to be straight lines here. Trying my best to draw a straight line here. And then we have 90.9 feet per second. And that's also for 2 seconds. And then the last interval here, we'll say is this one. It stays a constant 88 feet per second. And so this is again for 2 seconds. Okay, so this is an estimate. It's definitely not the actual distance because it's a little unrealistic here at the endpoints, but it's an estimate. So if you were to calculate this, you would get 821 feet. Okay, so there was nothing special about picking the beginning of the interval for picking my constant velocity here. I could have just as easily picked the end of the interval to determine the velocity. So let's see what would happen if we were to do that. So now I'm going to use the end of the interval to use as my constant velocity. So in other words, for this first 2 second interval here, instead of using the beginning, I'm going to use the end to determine the velocity during that interval. So this will look like this, which was 76.3. So now my distance is going to be 76.3 feet per second times 2 seconds. Plus, and now I will have something that looks like this. So that is 82.1. So that's 82.1 feet per second, again, times 2 seconds. Next, I have this interval right here. So let's see, what's that? That's going to be 90.9 feet per second. And again, 2 second long interval. Okay, 2 more. So now I have this one here. This one is 88 feet per second. For 2 seconds. And my last one is this one right here. Let's see, it's going to look something like that. And that one's 85.1. So that's 85.1 feet per second for 2 seconds. And if you calculate this, you end up getting 845 feet. And if you remember last time from before, when we did the estimates using the beginning of each of the time intervals, we had an estimate of 821 feet. So you see that they're kind of close to each other. The actual distance is probably somewhere around 821 to 845 because we don't know exactly what happened in between each of the sampling points. But remember, these are just estimates.